Okay, we're actually going to start the law of cosines today, and this is section 3.3, not 3.2, that's a typo. Alright, so the law of cosines is used also in triangles that aren't necessarily right triangles, but you can use the law of cosines to find a missing angle or side if you've got the proper information. And the first one we're going to do is for using finding a missing side in a triangle. And if you just look down here below, this version, or these three versions that are written here, are used when you have SAS information in a triangle. And SAS information would be when you have, for example, a triangle like this, if you knew this side, and you knew the angle in between the two sides. So side, angle, side. And you can see three different ways of writing the formula depending on which side you're looking for. Written up here, if you're looking for side A squared, it would be B squared plus C squared minus 2BC cos A, where lowercase letters, remember, are used to represent the lengths of sides, and uppercase letters are used for the angles. And these three versions of the formula basically are all written the same way, and the part that's on this side of the equal sign is basically the side that you're looking for. And that side that you're looking for squared will always be equal to the other two sides that you have squared, added together. So you square one side, then you square the other side that you have. And it's always going to be minus 2 times product of whatever these two sides here are. And then cosine of the angle across from the side you're looking for. And it will be the angle that's in between those two sides that you have. So let's try one of the examples. All right. So the first one there, you do have SAS information. You've got a side, two sides, 9 and 5, and the angle in between them is 60 degrees. So if we're going to look for the missing side, which is side AB, I'm just going to put X next to that rather than C, because sometimes the lowercase c looks like angle C. All right, so if we're looking for using the law of cosines, it would be C squared, lowercase c squared, my pen's not working, equals, in this case, it would be A squared plus B squared minus 2AB cosine of angle C. So I've replaced the little c with an x. So x squared equals A squared and B squared. Again, it doesn't really matter if you put A squared first or B squared first, but A squared in this case is 5 squared plus 9 squared minus 2 times 5 times 9 times cosine of 60 degrees is the angle across from the side you're looking for and in between the sides that you have. So that's 25 plus 81 minus 90 cos 60, which is going to be, if you put that in your calculator, should be 45. And then if we work that out, we've got, and the biggest mistake that people make here is they don't do all of this multiplication before they do the subtraction. So make sure you do all of that multiplication there first. So when we work that out, we get 61. So, and another big mistake that people make is they think that x is 61, but x squared is 61. So x is actually the square root of 61, which is approximately 7.8, if you round it off to the nearest tenth of a centimeter. 7.81 comes up on the calculator, which is approximately 7.8 centimeters. Okay, so the next example tells you some information here that calculates the nearest tenth of a centimeter of the length of DF in triangle. So DF is this one right here. If DE is 2.3, so this is 2.3 centimeters, and EF is 5.1 centimeters, and angle DEF is put in there for you at 62 degrees. So again, you have SAS, so you can use the law of cosines. So we are looking for, in this case, side E squared is equal to D squared plus F squared minus 2 times d times f times the cos of angle E. Angle in between the two sides you have, or across from the side you're looking for, whatever way you want to look at it. So again, I put x next to the side that I want. X squared equals, the side d is 5.1 squared plus 2.3 squared minus 2 times 5.1 times 2.3 times cosine of 62 degrees. And then you work each part of that out. 5.1 squared is 26.01 plus 2.3 squared is 5.29. And then 2 times 5.1 times 2.3 times the cosine of 62. Make sure your calculator's in degree mode. Is 11.0138. So that would be 26.01 plus 5.29 minus 11.0138. And that gives you 20.2862. So x squared equals that. So x would be the square root of that. Which is 4.5. 0, 4 around there. So x to the nearest tenth would be 4.5 centimeters. Okay, so we move to the next example. It says Monty travels 2.8 kilometers north to the dog park. So 2.8 kilometers north. And then he travels 1.8 kilometers southwest. So that would be south and west would be this way. I can't draw a straight line for some reason with this pen. Not sure why. Anyway, that's the best I can do. All right, 1.8 kilometers southwest to his favorite pet store. It says calculate the distance between his start point and his favorite pet store, which would be right here. So you're looking for that. If the angle between his start point and the pet store is 65 degrees. So this angle in here is 65 degrees. And you gotta answer to the nearest tenth. So again, you should kind of be used to the pattern now of law of cosines. So basically, you can letter diagram if it helps you, A, B, C, and then use your formula to figure out the missing side. But I'm just going to go with what I know the pattern is now. It's always the side you're looking for squared equals the side you know, square each one of those. So 1.8 squared, and add it to the other one, squared, 2.8 squared. And then it's minus 2 times the product of those two sides that you have, times the cosine of the angle in between those two sides, or across from the side you're looking for. So then if I work each part out, 1.8 squared, I get 3.24. 2.8 squared, 7.84. 2 times 1.8 times 2.8 times cosine 65 equals 4.5, 25, 999. So when I work that out, I get 3.24. I get 6.8200, and that's x squared. So x would be the square root of that. Second function square root of that gives you 2.6115, so on. So to the nearest tenth, that would be 2.6. kilometers. And that sounds reasonable, because look at the measurements we've got for the other size, 1.8 and 2.8. Now, my diagram here, this looks like a right angle here, but it's not necessarily a right angle, because that could actually be, it's not necessarily the largest angle, because this could actually be down, should be down probably less than that there. That's 2.8. Should look like that probably. Whoops. And then we're looking for this. Yeah. Okay. So that sounds reasonable, because like I said, this is 2.8, 1.8, and 2.6 sounds like a reasonable answer. Okay. Sometimes you're looking for an angle and you can't use the law of sines, but you do have enough information that you can use the law of cosines. And the law of cosines, we learned that there's basically 3 versions of the formula for the sides, but you can rearrange each one of these and come up with 3 corresponding angle formulas, I guess. And all the angle formulas, if you look at them, for example, cos of angle A, so if this is the angle that you're looking for, it's b squared plus c squared minus the side across from it squared, minus a squared over 2 times b times c. So it's whatever is added here is what's multiplied down here. So when you're doing cos b, if you're looking for this angle, that's the angle you're looking for, b. It would be equal to the sides that are around it, c and a are the sides that surround angle b, and the one that you subtract is the one that's across from the angle you're looking for. And then again, whatever the 2 that you add together here are the ones you multiply together down here. And similarly you can do for cos of angle C. So if you kind of look at it in general, the cos of the angle that you're looking for, the angle that you need, it's the 2 sides of the angle. You square those sides and add them together, and you subtract the side opposite the angle. So that's the one that gets subtracted, the one that's opposite the angle, the square of that. And then that's always over 2 times the product of the 2 sides that form the angle. They're the 2 sides that you are around the angle that you're looking for. So this formula can only be used if you have SSS information, basically if you have all 3 sides in a triangle. That's what SSS means. So let's do an example of that now. There's 2 questions here. An example 1. And the first one, you have to know a little bit about properties of triangles, and if the 2 sides are marked the same, that means they both have the same length. So now we've got SSS information, so we should be able to use the law of cosine formula to find that. So the formula says that the cosine of angle C is equal to a squared plus b squared minus c squared, minus the side that's across from that angle, squared, all over 2 times a times b. So if we fill that in, this would be cos of x degrees equals a squared would be your 11 squared plus your other 11 squared minus the side across from it, which is 8 squared, all over 2 times 11 times 11, which would equal 121. 11 squared is 121 plus another 11 squared is 121 minus 8 squared is 178 over 242. So you've got cosine of the angle is 178 over 242. So that means that the angle should be the inverse cosine of 178 over 242. And that will give you inverse cos of 178 divided by 242, which gives you 42.6 degrees, or approximately, to the nearest degree, right? So 43 degrees. So if we look at the second example, you have SSS again, so you should be able to use the law of cosines. So this one here, we're looking for cos of x degrees equals the two sides that are surrounding the angle you're looking for. You square those and add them together. And then you subtract the side across from the angle squared, all over 2 times the two sides that are surrounding the angle. And you work those out. 5.5 squared plus 4 squared minus 3.4 squared is 34.69 all over 2 times 5.5 times 4. And it works out to be 44. So you have cosine of x degrees. So x degrees would equal the inverse cos of 34.69 over 44. And you put that in your calculator, inverse cos of 34.69 divided by 44 is 37.96 degrees, so that rounds off to be about 38 degrees. All right. Okay, so now we're going to, this diagram here, the sides got blacked out, so it basically looks like this. Oops. This is 18.4. This is 16.2, this should be. These are all meters. And this should be 13.4 meters. So when we're looking for the smallest angle should be across from the smallest side. And the largest angle would be across from the largest side, and so on. So if we're looking for the smallest angle would be this one right here, because it's across from. 13.4 is the smallest side. So we would be looking for cos of theta would be the two sides that you want to square would be the ones that are around the angle that you're looking for. And you always subtract the one that's across from the angle squared. And then it's all over 2 times 18.4 times 16.2. And then you work each one of those out. 18.4 squared, 338.56 plus 16.2 squared, 262.44 minus 13.4 squared, 179.56 all over 2 times 18.4 times 16.2, and you get 596.16. And then go down one more step and simplify the top. So the top is 338.56 plus 262.44 subtract 179.56 is 421.44 over 596.16. So therefore the angle is inverse cos of that. Make sure when you're putting that in your calculator that your calculator is in degree mode and that you have brackets around the fraction if you're not going to change it to 1 decimal. So it would be inverse cos of 421.44 divided by 596.16, and that gives you approximately 45 degrees when you round it off. It comes up as 45.01 on the calculator, so that would be about 45 degrees. And so there's some questions there at the end of the section now that you can try from pages 150 to 152 that will practice some of the law of cosines.